Our speaker this evening has over 20 years experience as a DBA, of which the last 7 have been at Second Quadrant. Please welcome the Head of Support Operations for Second Quadrant, Marques.
Hi, how's everybody? So Eric invited me to this talk today to talk about PostgreSQL and how to back up and also recover your backups. So what I'm going to do is share my slides that I have ready. If I can find them, here you go. Great. So what we're going to talk about today is basically about backups in PostgreSQL. So first I'm going to do like an introduction to backups. What are backups for? We're going to just do some very basic talk about backups. We're going to talk about different ways to back up your Postgres databases. Then we're going to go a little bit into some disaster scenarios. That's very important because depending on the disaster scenario, you might want to choose one or another tool to recover. And once we go over the disaster scenarios, we can cover the recovery options for each one. And then at the end, we'll just move over some final notes, basically a roundup of the talk. So let's start by what are backups for? It's like, what are they for? Well, everybody knows what backups are for, even if, sometimes we forget to take backups of our laptop and then the laptop dies and we say, oh, what happened with my data? So firstly, it's to recover from disasters. Disaster can be anything. It could be a server that crashes, a server that gets destroyed for any reason. In the case of a laptop, your backups can serve as a recover from a disaster, like somebody stealing it. So maybe the laptop is very valuable, but the data might be even more valuable. In the case of databases, there's other reasons to take backups. For example, in Postgres, your physical backups can serve as a way to spin up replicas. So if you have a primary, you got a couple of standbys, and at some point you need to spin up a couple more replicas just so that you can, load balance your reads. You might want to spin them up, and that can be done very quickly from a backup. Well, sort of quickly. It also serves for creating staging and development environments. And if you have physical backups, you can also use the archive of the transaction logs as a wall hub. So if your standbys cannot keep up with the primary server, you can always just restore from your backup server. There's some pretty awesome tools that you can use. The one that we developed from Second Quadrant is called Barman. I might mention it several times during the talk today. So types of disasters to recover. So we're going to talk about first about types of recovery, and then we're going to talk about backups, and then we're going to talk about later on about backup types. So first of all, we're going to talk about the types of disasters. The first is the server is irrecoverable. We cannot recover the server at all. It could be for a lot of different reasons. Another is that the table is not recoverable. Maybe somebody dropped the table, maybe it got truncated, or for some reason we don't have access to it, or the data that is in it, we don't have access. Or there's some corruption and we need to recover. So server irrecoverable could be many reasons. It could be that the motherboard died, you got some memory issues, the server caught fire, Might seem unusual, but it is quite usual. Sometimes natural disasters like floods can also take away your whole data center. The case of a table gone, you could think of it as maybe the DevOps accidentally dropped or truncated the table. So you got the table if he only truncated it, but you don't have the data, so it's kind of useless. Data gone could be a huge number of reasons. One could be, for example, a deploy in your application and some query that is updating, deleting data. You missed the where clause, and then you just, each time it's executing, it's just deleting data that it shouldn't. And corruption can be for several different reasons. One of them could be a bug in Postgres. We haven't seen this very often lately, but about 6 or 7 years ago, there were a couple of bugs that generated some corruption. Nowadays, it's very common that if you see any corruption, it's mostly we end up finding out that there's problems at the hardware level. So, faulty memory or problems with some disk, and you get some data corruption, and you need to recover from there. So we're going to go over the ways to back up these contingencies, and then how to recover in each of the cases, or the best ways to recover. So let's talk about different backups types that you can have with Postgres. There's two main lines that you can take, or you can do both. One is to take logical backups, and the other is to go through physical backups. You can always take both. So logical backups are mainly the original logical backup is through the tool pgdump. So pgdump just does a dump and outputs the original version, just outputted a SQL file. So you can see the create tables, the alter tables, inserts, or in the normal default case, you'll see some copy in, copy out. You can also use pgdump in some compact, compressed version, so you don't see the actual SQL, but when you restore, it's basically just sending SQL commands to the Postgres server. Other ways to get a logical backup are to use logical replication tools. So since 9.4, you could use pglogical. Pglogical is the first logical replication tool that's available since 9.4. You can replicate from one server to the other logically. That means that it decodes the physical changes and replicates that to the other side. Since Postgres 10, we also have in-core logical replication, which also can replicate. So what you're doing with logical replication is just copying all or some of the data from your database to another server. And that could serve as a backup. You could also copy everything with logical replication. The other is to use physical backups, to take physical backups. So physical backups are available since version 8.1 or 8.2. So it's many years have passed. It's a very robust feature available in Postgres already. The original version was, which I will show shortly, was just to copy the physical files on disk. So physical backups are back up the physical underlying files. Just grab the files with any tool that you have available, copy, tape archive, async, whatever tool, copy them somewhere else, keep them safe, and copy your transaction logs. So basically, the tools that you could use, well, you can see there, you can use external OS apps. And since 9.1, I think it is, yes, 9.1, you also have available PG-based backup. I'm talking about 9.1, which is not supported anymore, but I'd like to talk, mention the history of PostgreSQL as well. So since 9.1, we have PG-based backup, which takes the backup using normal Postgres communication. So it will connect to the Postgres server through a normal Postgres connection, just like your application using libpq, and will transfer the backup. And then there's some specific tools. For example, pgbackrest. Barman uses async or pg-based backup. Other tools use their own protocol to connect to Postgres and download, actually copy the data files. Other types of base backup, physical base backups, are the standbys or replicas. So a replica is also kind of a backup. It's a server. It serves as also for HA, and HA is for disaster recovery. You got your server. It fails for any reason, and you want to fail over to one of your standbys. So the standby is also considered a backup. It could be synchronous. It could be asynchronous. And it could even be a delayed standby. We'll see a very interesting feature that we can use with a delayed standby to recover from a disaster, particularly from human errors. So it's very important to keep this in mind for some special cases. So for logical backups, we use pgdump to take the backups. I'm going to go very quick over this part. And we have pgrestore, which is the tool to recover pgdump backup. Even if it's not in plain text, if it's compressed, pgrestore is the tool to recover. You can also use pgrestore, for example, to just output the list of tables and objects that are going to be updated. So pros of logical backups. The first of all, and especially I'm talking about usage of pgdump and pgrestore. The first of all is that it's extremely robust. I mean, this tool is available since forever. It works incredibly well. I'm pretty sure that there's no bugs in it. It's really, really, really good. The backups are forward compatible because it's basically just giving you SQL output. So you can take backups from older versions and recover them perfectly on a new Postgres 12 or next month Postgres 13. You can also do partial recovers. So if you have a full backup of your cluster or of your database and you just want to recover one table, you can recover just that table. You don't have to recover everything. It's very flexible. It has flexible options for backup. You can exclude schemas, and you can do the same during recovery. So even if you have a full backup of your database, you can only recover just part of it. So it's very flexible. There's a lot of nice options. There's also some parallelism in it for the backup and for the restore. And it's very useful for verification of data integrity. So if at some point you need to verify that the data, that you have data integrity, that there's no dangling foreign keys around, pgdump and pgrestore are the best way to verify this. The cons, well, the first one is that pgdump needs to acquire a snapshot because it's basically giving you a snapshot of the database. That snapshot will hold back something that we call the xmin. The xmin is the minimum ID, transaction ID, of an open transaction. And that holds back vacuum from cleaning dead tuples, and also holds back some locks. Lightweight locks, but those locks can be a problem for stronger locks like an access exclusive lock. So having that snapshot for an extended time is not good. it's not good for the health of the overall of the database. So it's normally not a good idea to run a pgdump on very large tables, large databases in general. And as it takes a snapshot, a backup of a snapshot of the beginning of the execution of pgdump, it recovers to that snapshot. So you can't do point-in-time recovery. And as I mentioned, it's not really suitable for large databases. Anything above, I was going to say a terabyte, but I think that once you get above 200 or 300 gigabytes, I would just say that it's not suitable to use pgdump for the whole database or the whole cluster. Now, when we're going to see later that when you recover, sometimes you need to use pgdump to extract just part of the database, maybe a table or something. So that's the part about logical backups. Now we go to physical backups. So physical backups, I mentioned that it's available since like 8.1 or 8.2. I don't remember which of the two versions. This is one of the features that was introduced by the CEO of Second Quadrant at the beginning. So how do we take physical backups? So we mentioned that there's different ways. We can use OS or storage tools to take the backup. In this case, we will just configure wall archiving. We will run a command that comes with Postgres that's called pg_start_backup. This will initialize this serves for initializing the backup. It basically runs a checkpoint. The checkpoint is just write all the dirty pages in memory to disk. So you get everything that is dirty on disk, and you can start copying them without, you can start running your backup tool that copies the file, knowing that everything that was dirty on memory was written to disk. Then you can run, your favorite file system backup tool, async, tar. You can even take some kind of storage snapshot. You need to have, as I said here in this slide at the beginning, you need to configure wall archiving, because the walls are where all the transaction logs are, and we are going to need them to recover the backup. And at the end, we run the pg_stop_backup. Now, how does this work? Basically, you got your backup. Now, if you're copying the files from your backup, you might say, well, but this is an online backup. So the system is working, the application is connected, it's writing to the tables. You can have table A that has a primary key, table B has a foreign key, and then I write to table A, adding a primary key, and I write to B, adding another row that has a reference to A. But if the backup tool copied B before A, or the other way around, I could end up with a cluster that is not consistent, because I would have one data file of table A, of table B, that has dangling references to A. So it has references that do not have the appropriate row in A. So this is fixed by replying all the transaction logs again. So once you reply all the transaction logs, it will add the rows that are missing. And if there's a row that we already backed up, because it's already in the backup that we took, it just does nothing. It's like, copying over the same data to the page. The wall files are just going to apply physical changes. So it just grabs the page, applies the changes physically, and then saves them to the same place. So the pros of doing physical backups in this way, I'm talking about using OS tools or storage snapshots. Well, against pgdump, it doesn't hold any physical backup will not hold a Postgres snapshot. So it's only going to read from the underlying storage. You also have point-in-time recovery, which is very, very important. You can also do incremental backups. It is possible depending on the tools that you use. It's not possible with PG-based backup, but it is possible if you use the second quadrant tool, barman, with rsync. And also with rsync, with barman, you can do not only incremental backups, you can also do parallelism so that you can copy your backup a lot quicker and restore it quicker as well. There's a large versatile compression options that you can use, even with PG-based backup. So you could compress with PXZ, with bzip2. There's a lot of options that you can use there. And well, as I mentioned, it is also possible to do work to do the backup in parallels. Copy files in parallel. With barman, you can do it. We still don't have the ability of doing parallel backups with PG-based backup. That is a feature that's been discussed in the hackers list. So we might see this sometime soon. The cons of a physical backup are, I guess the number one is that you need to back up your whole cluster. So if you have like several databases running on the same cluster, what we call a cluster is a cluster of databases. You need to back everything up. That is mainly because the databases are in different directories, but there is a central catalog. So there are tables that are specific to the databases, but then there are tables that are common to all the databases. So if you think about it, PG database is a global catalog table. It's a table that has all the databases. So that's global to the whole cluster. And there are other tables from the catalog that are global. So you can't pick one or the other. There are tools, I think PG Backrest lets you select some of the databases that you wanna back up separately. The other thing is that PG-based backup doesn't back up configuration files outside of PG data. So you're backing up only, if you have, for example, Debian or Ubuntu, the configuration files by default are going to be in etc and not in your data directory. So in those cases, the configuration is going to have to get backed up from some other means. But it's not like super important because you might have the configuration files, like in some configuration system and maybe get them applied by Chef, Ansible, or Puppet. I mean, it is something to keep in mind. It might not be like, okay, it's important. Another way of backing up is by using replicas. So the replicas I just mentioned is also a possible backup facility. If we have a replica, something happens to our primary, we can always fail over. But not only fail over, we can also connect to the replica and probably extract data from it. So one option, for the two options that we have for replicas. One is to have like a very quick switch over to the replica. We promote it, we point our application to the replica, and everything is back up, like a backup. But the replica can serve other means. For example, if we set it up with a recovery min apply delay, we can have the replica delayed from the primary. So we can give it like 1-2 hours of delay. I've seen even customers using 24-hour delay from the primary. So what you have there is a replica that has data from 1 day if they have 24 hours delay, 1 day old data. So if something happened in the middle, you could use that replica. So the pros of the standbys. Number one, you got lower RTO. So this is recovery time objective. That is because you can switch to a replica very quickly, just promote it. There are some tools that can promote replicas so quickly that the application basically doesn't even notice that there was a change in the architecture, that one of the replicas was converted into a primary. You can also achieve RPO 0. So this is a recovery, point objective instead of time, 0 with a synchronous replica. So you could have synchronous replication, and in this case, you would end up with 0 data loss. Also, with a replica, the replica is always running. You can actually run queries against it. So you basically have a warm cache. You don't have to warm it, which is what would happen if you recover a physical backup from a server that is not running. There's many tools available to manage the failover in case you need. Second Quadrant is offering a rep manager. There's another tool that we are working on. There's also other tools like PG Failover, Patroni, and others. The cons, well, first of all, I was going to say larger infrastructure because you need more servers, but nowadays, I mean, with how cheap disk space is, how cheap servers are, you can go to the cloud and just bring up, instances in Amazon or Google. So it's not really, I would say that it was a con many years ago, not anymore. Now, in the case of synchronous replication, there is a performance impact. So if you decide to go that way, make sure that you understand the impact of synchronous replication. It really means that from the application point of view, you do not get the acknowledge from the database server that the commit was effectively committed until that change lands, actually is written, and probably even replied, depending on the configuration that you use, on the standby or the standbys. That also depends on the configuration. So, backup considerations. Things we need to consider for a backup to be complete. First, it has to finish successfully. So whatever tool we use to back up, it has to return 0. It was successful. Else, the backup is useless and we need to start again. It has to be located in a remote site. You cannot have your backups right aside of your primary server or the server that is being backed up. It has to be somewhere else. Yeah, that's, I said about the disaster, one of the disasters that I mentioned was the flood. If your whole data center gets flooded, your primary goes down, your backup goes away, and you have no way to recover. So always have your copy somewhere far away from where you are, where the server that you're backing up is. There's somebody told me many years ago, we were at a table at one of the conferences and we were talking about backups. And he mentioned that he was working with somebody who had the company in San Francisco and they had a very large Postgres database there. And they wanted to set the backups. And he said, well, you need to put the backup away from where you have your primary server. And the guy said, oh, okay, well, we can put them in Oakland, across the bay. And he was like, oh, come on, you can't put them in Oakland. You got a huge crack there that you can just lose everything if there's an earthquake. So I guess he got them to actually move the DR site to somewhere far away. I think like Las Vegas, something in Nevada or Colorado. So that's very important. Very important. Very important. Backup and restore process have to be documented and, if possible, automated. You have to have everything well automated and documented. Everybody has to know how you take your backups and how to recover them, especially how to recover them, because the minute that you need to use your recovery is where the documentation is not found. Somebody said that you should have it documented and printed and stapled in the front door of your of the data center, so when you're going in, you can already read it. Don't have it inside a machine, please. It has to be printed. The instructions, I mean, not the backup. And most importantly, a restore was attempted successfully. In order for a backup to be fully successful, you have to be able to restore it. And the only way to know if a restore is possible is to actually restore it. So this brings us to this, our first and I think the only image in this stack of slides that I have today, which is the famous Schrodinger's backup. The condition of any backup is unknown until a restore is attempted. After you restore, you'll know if the backup is a backup or not. If it fails, then it's not a backup. Okay, so we went over what a backup is, different backup types in Postgres, and we also talked about, and we finished with some backup considerations, what a backup is and how can we consider a backup completed and useful for us in the case of an event. Now we're going to talk about recovery, how we recover the backup, because having a backup is very nice, but if we don't know how to recover it and we don't have it documented, then we're into other problems. So first of all, I'm going to talk about, I did some very nice ASCII drawings, which I really like, just to illustrate, in a timeline, how backups work, physical backups work in Postgres. So let's say that at time 1, we take a base backup. So that is basically we run a PG base backup, or we just did a PG start backup, copied all the files to a remote site, and it finished with a PG stop backup. Once we finish the base backup, well, we keep archiving our walls. So let's say, got day 1, day 2, day 3, day 4, 5, 6. And in the meantime, we're just archiving the transaction logs. So we got all the transactions and we got a base backup at time 1. At time 5, we have an incident. What's an incident? It could be anything. It could be the cluster crashed and we can't recover from a standby, or it could be that someone dropped a table. Maybe some accident happened, somebody, or maybe we were supposed to truncate table A and we truncated table B, and B was very important. The data was very important and we need to recover it right away. So how do we recover? We had a backup and we had a lot of walls archived. The walls are where our transactions are. So now what do we do if at time 5 we had an incident? We are at time 6, for example, but we need to go back to time 5 where the data was actually in good shape. So what we do is we basically recover the base backup, which is at time 1, and then we start replying the walls. Replying walls is just replying again all the changes that were happening while the server was up and our applications were connected over. We get to the target, the recovery target here at the end, and we stop there. When we stop, we have the actual data without any loss. The loss came after the incident. So we recover just before the incident. This is basically how backup and recovery works. I hope the drawings illustrate it correctly and everybody can get a sense of what's happening under the hood. So we talked about the different disasters that we had. We had the server irrecoverable, we got the table gone or the data gone, and we had the corruption. So those were like the three types of disasters that we talked about earlier. Now we're going to go over how to recover, or the different options that we have to recover for each of these three. So let's start with the server irrecoverable. So option one, we can pick up a standby if we have a standby available, and the standby is it hasn't lost the data. Then we can just pick a standby. If there's more than one, we can pick the one with the highest LSN. The LSN is just basically the point in the timeline where the server is writing. So the LSN is like a sequence that moves forward. The standbys will be at an LSN prior to the primary. So it could be, depending on the lag of one and the other standbys, that one is closer to to where the primary was writing, and others are farther behind. We want to find the one that is closest, so the one that has the highest LSN, and we promote it. Promotion is just making the standby a primary node. At that point, if there are other standbys, we just reconfigure them so that they connect to the new primary, and we, if possible, obviously, if maybe the primary crashed, but then later we were able to recover it, we can transform it into a new standby. So we're basically just changing the roles of all the nodes. If we had like 4 nodes, one was the primary, the other 3 were standbys, we're just switching roles between them and keeping the 4 nodes, obviously if the old primary is able to come back up. If this was some kind of Kubernetes environment, Kubernetes would take care of everything. It would just bring up a new node. It would promote, then it would just, drop the old primary and just recreate it, create a new one. But you can do the same thing with other tools like Patroni or even with Rep Manager and some automation. So this is option 1 of server gone. Option 2 is in the case that we don't have replicas, or that the replicas are not useful for the means that we want to get to. We can always recover from a base backup, a backup that we have. Let's say we have the primary and we have a backup server, and we have all the WAL files in the backup server. So what we can do is just bring up a new server. If we were in Amazon, we would just bring up a new EC2 instance, and we would recover from the latest backup, and then replay all available archive WALs. So we got the base backup, and then we start replaying all the WALs, and at some point we reply the last one, and the server is up and running with all the transactions. It's possible that there is some data loss in this case, because we need to have all the WALs from the instant at which the server crashed or disappeared for some reason. So there might be a few missing WALs unless you have your backup server with synchronous commit. So that is with server gone. Now we're going to talk about how to recover in the cases of a table with problems. When I say a table gone or data gone, it could be, for example, the table is there, but it has no data because somebody truncated it. It could be data gone because there was probably a bug in a deploy, and so the deploy had a wrong query, and the query is just chewing the data off. And so it's deleting data or updating data that it shouldn't update. So ways to recover from this. The first option is to use a delayed standby. This is why I mentioned the delayed standby. It's very useful in this case, because let's go to the hypothetical that you truncated the wrong table. So you had to truncate B and you truncated A, or vice versa, and it was very important, the data that you truncated. If you have a delayed standby, let's say it's delayed by 1 hour, you can always connect to the standby, check if the data is still there, and if it's there, you can pause replication so that any changes, what you don't want is the truncate to get from the primary to the standby and get replied, and so the table on the delayed standby gets truncated as well. So before that happens, you pause the reply, and you can dump the data from the replica. So you have the delayed standby, which has the data that you destroyed accidentally. You can dump it, and you can restore it on the primary, and then you can resume reply. So what's going to happen on the delayed standby is that when you resume the reply, now you have your data because you already extracted it using pgdump. In this case, you need to use pgdump. So you resume, the truncate comes in, it truncates the table, but you already have the data and you are merging it on the primary. So you're reapplying it on the primary. And then that merge of data that you put on the primary comes into the delayed standby. So this is very useful, and you can actually recover just one table, for example. Okay, option 2. This is a more detailed version of option 2. So this is basically what I just mentioned. You just check that data is still available on the delayed standby. You pause it. You can use options like recovery target time, or there's also some other options of recovery target that you can use, but time is like the most useful one. And then you can use recovery target action to promote. In this case, what we're going to do is just, if we set recovery target action to promote, we're basically saying, okay, recover up to this point and then just promote yourself as a primary. And then you resume reply. So in this particular case, instead of extracting the data and putting it in the primary, what we're going to do is use the standby and promote it as a primary, but we're going to promote it just before the disaster happened. So if we know the exact instant at which the data is lost, we can set it just a few seconds before and promote that as a new primary. This provides less downtime. It's super quick. It's basically like doing just a promotion in high availability. It's a lot simpler, but there could be some data loss. Why? Because from the moment that you realized that some data was lost, or that you ran a truncate in the wrong table, and when you actually are able to recover, in the meantime, the application is still connected. It's writing to your database. So all the data in between those two intervals will be completely lost. So you have to keep that in mind. Sometimes it's more important to get things up and running with certain data and lose partially lose some other, which might also be recoverable. It might be harder, but it would be recoverable. But sometimes it's better to get it back up and running as soon as possible, especially if the table that got lost is a very important one, like a table that if it's not there, nothing works. Maybe the application doesn't work either. Okay, and this is the option 3. So using logical backup. In this case, we're not using physical; we're using logical. So if we have PG dumps and we have the same problem with the table that got disappeared, we can use the PG dump, just extract one table and merge it into the primary. So this is a case where, for example, if the table is static, it doesn't really have changes, you could use maybe a PG dump from the day before, and that is completely fine because the table is static. It doesn't really change. In other cases, that's why I say there may be data loss, because the PG dump, a logical backup, is, from a snapshot from before. So for static tables, it works very well. For tables that are receiving DMLs constantly, it's not really a good option, especially if what's in that table is very important. Okay, so we got option 4 of table data gone. This is probably the least optimal, but the most used, especially on really big databases. What we're going to do here is just recover the whole base backup and set a recovery target time. So we recover to that time. So the recovery target time has to be an instant right before the disaster happened. Then we extract the missing data, we apply it on the primary node. Or another option is just, we recover to that time. We can check data, how, what data is there, if it's exactly what we're looking for. And if we think that is a candidate for primary, we just promote it and use that as a primary node and then reconstruct all the cluster around it. So we talked about the server gone. We talked about data getting corrupted. And then we got, about a table or data missing. And now we're going to talk about data corruption. So data corruption, file system corruption, or missing files. Sometimes we talk about data corruption as, well, the disk is failing, or we got a faulty memory bank or something like that. But sometimes it could be just the user that deletes data from the PG data directory. And this is a very important advice that I give. Do not manually touch any files inside PG data. You have to be 200% certain that what you're going to do is not going to affect the data. And normally, touching any file inside PG data will compromise your cluster. It's the reason why we normally recommend having the Postgres logs outside of PG data, so that you don't get confused and start deleting, saying, okay, I'll delete log files, and then you end up deleting files that are actually important for the cluster. So, and there's even stranger ways of corrupting your data. For example, running an antivirus on your database server. You might think it's uncommon, but it's actually very common, especially when running databases on Windows machines, but also on Linux. Don't get surprised if you see ClamAV running on a Linux server. So normally what you have to do, if you need to run your antivirus because you need it for policies of the company, it's okay. Try to exclude PG data and especially do not quarantine your files. If the antivirus finds a file that is a candidate or thinks that it's a file that should be that looks like a virus, then just report it. Do not quarantine it immediately because it could not be. So it's better if somebody manually does that. Back to the backup. So now we talked about another type of ways to corrupt besides faulty memory or faulty disk. So almost, as I mentioned out here, I got some points here. Almost always the only option, if you have corruption, is to take a physical backup and recover. So you're going to go to your backup system, Barman, or if you're using some other tools, you recover your backup, you just reply the walls to a consistent state, or any LSN that you know is before the corruption happened. You might even have to recover several times. You want to start moving forward until you see corruption. Remember, this is physical backups. So if there's corruption in the underlying disk, it will be copied over to your backups. So you need to find a backup where the corruption didn't happen yet. Then verify if the good, well, this is just what I just mentioned. Just check that the corruption isn't present in your backup until you can, you find the version where you have the most of the data that you had, but without the corruption. So you need to find when the corruption happened and recover to an instant before. Basically what you would do here is pause, reply, then move the recovery target time a bit further, then resume and see if the database is corrupt. The problem is that the minute that you got into corruption, you cannot redo. So Postgres always moves forward. You cannot move back. If you need to move back, what you'll need to do is get a new base backup, or recover again backup and do the same dance moving forward until you get all your data. Okay, so finished talking about recovering. So we got our final notes or conclusions. So first of all, very important, take backups. That is mandatory. There's no exception to this. You need backups. And obviously, if try to get some kind of automated tool. I always remember when backups were introduced into Postgres. I wrote my first backup tool, which was a very small script in shell, bash script. But this was like 15 years ago. It's something that I wouldn't do now. First, because I have a lot more experience, and because there's a lot of nice tools available that do all the work, and I don't need to, take care of what happens if I get an error from here or from there. Personally, I recommend using Barman. I know that others would recommend other tools. In any case, the first thing is use a tool that automates the work of taking backups and recovery. Another conclusion that is part of this talk is that standbys are vital for backups, and they can be used in different ways to recover from different types of disaster, even not only full cluster disaster when the primary goes down, but they can also serve for recovering partial data. Always test your backups. And the way to test your backups is by recovering them. There's no other way to be fully sure that the backups finish correctly. Well, and delayed standbys are actually very, very useful if you need to recover from certain kind of incidents with a very low RTO. So it's an option. I'm not saying that everybody should have a delayed standby, but keep it in mind, because delayed standbys is a feature that was added to Postgres for this specific case where you want to recover a huge, let's say you have 12 terabytes and you need to recover the 12 terabytes. That means copying 12 terabytes of files. If you have a delayed standby, you can recover a lot quicker, just waiting until the instant before the issue happened. And this is a nice feature that Barman has, where you can use wall streaming to your backup server instead of using archive command. So archive command will just, execute a command each time a wall file gets filled up. So instead of copying the wall files to your backup server, you can stream them using PG receive wall. And in the case of Barman, you can set the wall receiver to be a synchronous one. So if you are synchronously copying to your backup server, you have RPO 0. You have 0 data loss. You're not going to lose anything at all. Very, very useful, for when your data is so important that you cannot lose even one transaction. This is what you need. Well, and obviously, security first, encrypt your backups, please. At rest, at least at rest. So, questions? Eric, I leave the mic to you.
Guys, if anyone has questions, please type them in the chat, and we're going to take them right now. And also, I want to give a great big thank you to Martine. That was a great presentation.
You're welcome.
I tell you what, while we're waiting for the questions to flow, let's give away this Postgres book right now. The way we're going to give this book away is pretty easy. I wrote down on a piece of paper that you guys can't really see right here a number that is between 1 and 100. Just type in the chat any number, and if the first person to get whatever number it is, I'll show you it on the screen, and they're going to win. And it's not, I'll tell you when it is. Keep typing, guys. No, it's not. I haven't seen it yet. I would do higher and lower, but it's going too fast. It's lower than the 53 that someone just put in there. It's higher than 10. Holy cow, that's hard to read. Higher than 14, lower than 25. Lower than 33, lower than 21. Oh, there we go, we got it. Stop typing, I can't read it that fast. Ali Nawaz, you indeed got it. It was 18. So Ali Nawaz got the book. Congratulations. Now put your questions into the chat, because everything that was written there is now scrolled 10 screens higher. So guys, put some questions in there. We had a question during the presentation from Tom Brown that was, what was your favorite, your personal favorite approach? And I no longer recall what the context of that question was. Tom, if you can put that back in the chat, we'll answer it. Ali Nawaz wants to know any tool for working with RDS.
Surely there's no backup tools outside of RDS, physical backup tools outside of RDS. RDS takes care of the backups itself. It's like a it's like everything in Amazon that is as a service. It's they have everything packed up, very nice with a console. You just press a few buttons, you can upgrade, you can take backups. I believe that when you tell it to take backups, it actually takes physical backups. So it might take like an EBS snapshot of your instance, and you can recover that at any other time. For logical backups, you can use any of the other tools available. You can connect with your application, you can connect with pgdump. So you could take a pgdump just like with any other Postgres database. And there's pglogical as well available.
Ali says we use well, it's just scrolling
Yeah,
down. We
DMS
use
for logical.
DMS for logical replication, but sometimes it's too slow.
Yeah, I really don't know DMS. I know it's something. I guess it's something from RDS and Amazon, but I really don't know it, so I couldn't comment on that.
Tom Brown wants to know what's your personal favorite backup and restore, given that data is important in real time, and you don't have unlimited budget or disk space.
Well, the idea of the talk was to like put all the cards on the table, you know, and depending on what you need at any time, you might want to choose one option or the other. I know the budget is not unlimited, but my personal favorite is to use Barman to manage your backups and always have at least one standby. I guess that if the data is very, very important and you can work on, for example, if you're on Amazon, have a couple of nodes in one availability zone, have one or two nodes in another availability zone, and then set up your backups accordingly. Maybe Barman still doesn't have, well, it does partially have available options to ship your backups to S3. So you could use something like have one backup available locally and then the rest in S3. Remember that S3, it's unlimited, but it's very slow. So recovery is going to be slow.
All right. Does anyone else have more questions? Put them in the chat right now. All right. I'm going to, oh, wait, we got one. Gabe. Gabe writes, hang on, do you trust? I kind of struggle to read that. Do you trust cross AZ or would you rather have cross region? What is AZ abbreviated as?
Availability zone. Well, I mean, the thing with cross region is that it's very slow. I would trust different availability zones because those are basically from the Amazon point of view, they are like almost different data centers. I actually think they are different data centers in the same region.
All right, for those who want anything, I'm going to email you probably in about a day or so to get your address, where to mail you the Postgres stuff from Second Quadrant, and the book, of course, to Ali. And beyond that, if you have more questions, we'll keep this rolling probably another minute or two, where you can ask Martina, and I'll unmute your microphone if you want to. Other than that, thank you so much. I want everyone give a clapping. There's a clap tool under the reactions on Zoom. Everyone give a great big round of applause to Martine. Thank you so much. I know I'm the only one you can hear. It doesn't sound so impressive.
Thanks, Eric. It was very nice.
It was an excellent presentation, Martine. Thank you.
Yeah.
All right, we're hitting the 80-minute mark, and I'm going to call it a night. Thank you all for coming. See you all at the next video.
Bye-bye.